physical properties of alcohols. In the first part, we will be looking at the physical state of alcohols. If the alcohol have carbon more than 12, it exists as a solid, and if the alcohol contains carbon less than 12, it exists as a liquid. Methanol and ethanol are volatile liquid with boiling point 65 and 78 degrees C respectively, while phenols are colorless liquid. The next part, we will be discussing about the boiling points of alcohols. So for the boiling points of alcohols, I will divide it into 5 different categories. So the first category is when alcohol versus alcohol. So we have 2 examples here, 1 butanol and also 1 propanol. So as you can see from the structure, we know that 1 butanol has a greater number of carbon than 1 propanol. So meaning to say, the size of 1 butanol is greater than 1 propanol. Therefore, the contact surface area between 1 butanol is greater than 1 propanol. The van der Waals force of attraction between 1 butanol is stronger compared to 1 propanol. This will make more energy is needed to overcome the force of attraction between 1 butanol compared to 1 propanol. Therefore, 1 butanol will have a higher boiling point than 1 propanol. The second category is when we compare the straight chain alcohol with the branch chain alcohol. So in this case, we have 1 butanol versus 2-methyl 1-propanol. So as we look closely, the number of carbon for these 2 structures are the same, in which both have 4 carbon. Therefore, they have the same molar mass and only 1 hydroxy group attached to the structure. But the difference is 1 butanol is a straight chain, while 2-methyl 1-propanol is a branch alcohol. And actually, branch alcohol has a more complex structure, resulting 2-methyl 1-propanol has a smaller surface area compared to 1 butanol. So we can conclude that the contact surface area of 1 butanol is greater compared to the 2-methyl 1-propanol. The van der Waals forces for 1 butanol also is stronger than 2-methyl 1-propanol. This will make the more energy is needed to overcome the force of attraction between 1 butanol and 1 butanol will have a higher boiling point compared to 2-methyl 1-propanol. The third category is when your alcohol exhibit positional isomers. Positional isomers meaning to say the position of OH is on the different carbon. Okay, the number of carbon is still the same, but the position of the functional group is different. Here, we will be using 1 butanol and 2 butanol as an example. So for 1 butanol, the OH group is at the end of the chain, while for 2 butanol, the position of the OH group is at the middle of the chain. So we can conclude that 1 butanol and 2 butanol are isomeric to each other. However, the position of the hydroxy group are different. The hydroxy group of 1 butanol is at the end of the chain, making it more exposed and able to form the hydrogen bond more effectively compared to 2 butanol. More energy is needed to overcome the force of attraction between 1 butanol molecule compared to 2 butanol. Therefore, the boiling point of 1 butanol is greater than 2 butanol. The fourth category is when the alcohol versus other organic compound. So in this video, we will be using alkane versus alcohol. For more specific, butane versus 1-propanol. So for your information, butane and 1-propanol has similar molar mass, in which butane punya molar mass adalah 60 gram per mol and 1-propanol punya molar mass adalah 58 gram per mol. But 1-propanol has OH group that can form hydrogen bond between its molecule, while butane can only form London dispersion forces. And as you know that the hydrogen bond is stronger than London dispersion forces, therefore more energy is needed to overcome the hydrogen bond in 1-propanol compared to the London dispersion forces in butane. Thus, the boiling point in 1-propanol is greater than butane. So the last category is alcohol versus diol. So for this comparison, we have two structures of alcohol, one structure with 1 OH group and the other structure with 2 OH group. So the name for this compound is 1,2-propanediol and the other one is 1-propanol. For your information, the boiling point of alcohol increases as the number of OH group increase. The greater number of hydroxy group, meaning the greater number of hydrogen bond, can be formed per molecule. Thus, more energy will be needed to overcome the force of attraction between 1,2-propanediol compared to 1-propanol. Therefore, boiling point of 1,2-propanediol is greater than 1-propanol. So, ini adalah carta alir untuk memudahkan kamu ingat 5 kategori untuk perbandingan boiling point of alcohol. The next part is solubility in water. We already know that alcohols are soluble in water. This is because the hydroxyl group in alcohol is able to form hydrogen bonds with water molecules. Alcohols with smaller hydrocarbon chain are very soluble, but as the length of hydrocarbon chain increases, the solubility in water will decrease. Why? So as you can see from this diagram, this is how alcohol will form hydrogen bond with the water molecules. So actually, alcohol molecule contains a polar end, which is the OH group, and a non-polar end, which is the alkyl group. The polar end is soluble in water, so we call it as hydrophilic area, while the non-polar end is insoluble in water, and we call it as hydrophobic area. OH group is polar and it will form strong hydrogen bonds with water molecule, but the hydrophobic area will have weak interaction with water molecules. Therefore, as the length of the hydrocarbon chain increases, the solubility in water will be decreased. Thus, alcohol with carbon more than and equal to 5 is insoluble in water. Now, let's take a look what happens when the number of OH group increases. So actually, when the number of OH group increases, the solubility also will increase due to the increase in the number of hydrogen bond that can form with water molecules. So we have these three structures here. So we label it as A, B, and C. The order of decreasing in terms of solubility is C, B, A. And the order of decreasing in terms of boiling point also will be C, B, A.